So, we have seen pasteurization low temperature, low time, also high temperature, high time. Perhaps high temperature, high time we will discuss a little more. So, in this dairy and food process and products technology course, we are in lecture number 43. We also will try to cover up the effectiveness of pasteurization, that you have pasteurized, how much it is effective, right. So, that should also be known. So, whether pasteurization is correct or not. So, how to know that? So, there are some process, some techniques by which you can know that how the pasteurization was effective or not, how whatever you have done is good or not, that should be known. So, we will do today that also, along with maybe some high temperatures, high time or high temperature short time pasteurization, right. So, how to test for the effectiveness of the milk pasteurization? So, high temperature pasteurization denatures peroxidase. So, peroxidase is an enzyme, right. So, this is highly heat resistant enzyme peroxidase. So, if the enzyme peroxidase is inactivated, then we can call that the pasteurization is effective, right. This is one. There may be some other techniques also. So, peroxidase test is one of them, where if it is denatured or if it is destroyed, then it can be said that pasteurization is okay. The enzyme is more resistant to heat treatment than all pathogenic organisms or microorganisms found in milk. And if the heat treatment is sufficient to denature the enzyme, then it is a confirmation that all the pathogenic organisms are also destroyed or killed, right, by this process. So, properly pasteurized milk should give a negative peroxidase test. A peroxidase test if you perform, so that should give you a negative test, right. Now, another way is that alkaline phosphatase test, that may not be very reliable, because research has shown that it can be reactivated, especially in pasteurized milk as high fat content, right. So, as I said, now there are many techniques by which you can know, you can judge pasteurization was effective or not. So, in earlier times, that alkaline phosphatase used to be taken as one of the target test or one of the tests by which the effectiveness of pasteurization can be judged. If alkaline phosphatase used to give you negative result, that means pasteurization is effective. But afterwards, subsequently, research on this have studies on this have revealed that the alkaline phosphatase is not good enough, because it may reactivate some of the organisms which might not have been killed, but phosphatase might have seen to be negative. So, that pasteurization reactivates that phosphatase test. So, that is because high fat content in the milk may reactivate that some of the phosphatase, and it may not be again negative. So, that is why it is not dependable, whereas peroxidase test, if it is negative, then confirmedly you can say that your pasteurization process that is heat killing or heating method, that was absolutely okay, and you can depend on this result, right. We may again come back to HTST because some more things are to be said about HTST, that is high temperature short time. So, this type of pasteurization is also known as the flash pasteurization, because time requirement is very low. Flash pasteurization involves heating milk to 71.7 degrees centigrade for 15 seconds to kill the target organisms, that is your Coxiella barneti, that can be killed at 71.7 degrees centigrade for 15 seconds, which is the most resistant pathogen in the milk. In raw milk, this is the most resistant pathogen. Since it is technically impossible to bring the milk to that exact temperature, normally it is always safe to work with a range of temperatures, right. To be safe, we can do it that milk heating between 72 to 74 degrees centigrade for 15 to 20 seconds. This is for all precautionary purpose, that coming exactly on 71.7 degrees centigrade, maintaining it for 15 seconds may not be all the time technically feasible. So, from the technicality or from the technical point of view, you increase the temperature a little by some decimal, like 71.7 to 72.3 degree is nothing, or 72 to 74, within that temperature if you can hold it for 15 to 20 seconds, then you are safe that your pasteurization, that is high temperature short time pasteurization, is over, and you can be very much safe that it will not cause any infection to the consumer. This will ensure that the milk is heated uniformly to the required temperature, and this method is most suitable in continuous pasteurization systems, because we said there are the batch pasteurizers are normally for LT, that is low temperature long time, but high temperature short time, that can be your batch, or that can also be continuous, because your time duration is very small, 15-20 seconds. So, that is the holding period. So, if your heat exchanger is this, inlet fluid is coming from here, exit is going from there, within this it is staying within 15 to 20 seconds, that is their whole exchanger is at 72 to 74 degrees centigrade, and you are allowing it to inlet to exit 15-20 seconds, and that is good enough for killing all organisms, because you have killed that target organism, that is Coxiella barneti, right. So, Coxiella barneti is the most resistant pathogen. If that is killed, all the organisms are killed, pathogenic organisms, of course, right. Then flash pasteurizers or pasteurized milk will keep for between 16 and 21 days. For commercial reasons, some manufacturers intentionally reduce the number of days to push the products out of the shelves, because if it is lasting for 20 days, right, then the cell may be depleted. So, to avoid that, the manufacturers might make it purposefully that no, it will not last for 20 days. So, 5-7 days by which you have to consume, otherwise it is not safe. So, that the demand remains in the market. So, that is business tactics, not the scientific practice. Scientifically, 72 to 74 degrees centigrade for 15 seconds good enough to keep your milk for around 20 days safe, right. Standard milk pasteurization system consists of the following parts like balance tank that maintains a constant head for the incoming milk, milk feed pump which creates suitable pressure that is necessary for efficient flow, flow control system that ensures sufficient amount of fluid in the conduits at any given time, filters and clarifiers that removes the dirt from the products, then homogenizer that divides the fat globules into microglobules to avoid fat separation in standing milk. Of course, homogenization will come separately in detail, because that is also one very vital step in milk processing. Like pasteurization is one, similarly homogenization is another, also standardization. So, these three will cover either in this or subsequent class very thoroughly, right. Then we come to this, that PHE, that is plate heat exchanger, where this heat transfer takes place, right. Plate heat exchangers are like that, so many plates are there, right. So, alternatively this may go like this, okay, and may come like this. This is one way, and if I could change the pen color, however, I do not know how to make that. So, let us give the arrow. So, if this is your 1 and this is that 1, another this way it is coming. So, another thing may be like that, it is going like this, like that, like this, right. So, that may be another. Now, depending on this flow in PHE, I am not of course discussing much on PHE, because then we will be covering the entire world, not possible. Plate heat exchanger, where plates are there, and depending on that, say a plate looks like this, right, and it has 4 holes, 1, 2, 3, 4. So, depending on which hole is open and which hole is closed, say this one. So, it will come here and fill up and then go to the next by this, and then depending on the next one to where it is open, maybe this and that. So, where it is open, maybe say this one is open and all these are closed. So, there it will go out. So, like that, the ports are arranged in such a way that in one plate it will be the milk and the other plate the heating medium. Normally it is steam, right. So, that way the plate heat exchanger works, right. So, when you are using plate heat exchanger, then you can have the regeneration. Now, regenerator means that your, as again we said, so if your milk has come like this, so this milk, it was at an inlet temperature of say 40 degrees centigrade, say, or say 30 degrees centigrade room temperature. Now, it is heated to 73 degrees centigrade, right. Now, this 73 degrees centigrade you have to cool, right. So, this extra heat if you can extract, then that becomes pre-cooling for the other, or pre-chilling for the other, preheating for the other. So, that preheating can be done, which is at going at 30 degree. Now, if that can be made, so that is again getting heat exchanged, so that the exit which came out at 73 degree centigrade, lot of heat can be removed from that. That is what is the regeneration, right. Where in PHE this regeneration or heating or holding and cooling, this can be done. These sections are also very much important. The facilities efficient pasteurization for these selections are required. These selections are required. Flow diversion valves are there that ensures that all the conditions for pasteurization have been met before the milk assessed through, because ultimately the pasteurized milk will be assessed whether it is pasteurized or not. So, before that is done, so you have correctly pasteurized, that will be controlled by the flow direction valve. Instrumentation and control equipment, that is one of the primary, because instrumentation and control will dictate whether the time temperature combination has correctly done or not, because based on that your pasteurization efficiency will depend. So, that is one of the primary your selection or section process, primary section when you are selecting. Increases system efficiency and reliability. Peripheral sources of utilities such as steam, air and water. In most of the cases, as I said, the heating medium is steam. In most of the cases, heating medium is steam, but in cases it can be water also, right. Normally, air is not used, air is maybe used for cooling, but not for that, right, because air is not a good medium for heat transfer. Here you need that efficiency to be high. So, steam and water normally is used, hot water. So, that provides the necessary utilities for heating, cooling and pasteurized environments. Then conduits piping system, there are, because if it is not a small unit, if it is a large unit, so there maybe from one end to other end you have to move several meters or several tens of meters, and in that case that piping properly to be done. One good example, if you are very close to mother dairy or Amul, right, you can visit and see how exorbitant those systems are, right. Then this facilitates flow of milk and utilities from one point to the next point. Each of the pasteurization sections has been designed to increase the efficiency of the plate heat exchanger. Ultimately, your plate heat exchanger efficiency has to be used. So, what you are doing? You are regaining or regenerating the heat, so that your efficiency of the plate heat exchanger goes up. And again, when you learn PHE, plate heat exchanger, then you will see that co-currency and counter-currency, these are the two terms which are very important. We know that in any heat exchanger, when it has come up here, let me also tell that if any heat exchanger, if it is a parallel heat, right, if it is a parallel heat transfer, then your curve looks like this, right. And if it is a counter current heat exchanger, then your heat transfer looks like this. So, depending on whether the flow was parallel or counter current. So, that word which is coined as co-currency or counter currency. So, how much co-current, how much counter current, that will depend on your flow in the through the plates. So, if in one case it is co-current or in other case it is counter current, then your efficiency will be differing. Counter will be better than the co. So, how much co-current, how much counter current, that will also depend, that will also dictate the efficiency of the heat exchanger PHE, right. So, this you have to keep in mind. Then movement of milk through the PHE for an effective pasteurization. Chilled milk from the bulk milk tank at 4° centigrade moves into the balance tank, from where it is pumped into the regeneration section of the PHE. Regeneration section means where the output is again passed through this input. So, that there is also an heat exchange and you are gaining some heat from the already pasteurized milk. They are not coming directly in contact of course, but heat exchanger through the PHE it can be done. So, that is another thing. At the regenerative heating section of the PHE, chilled milk receives heat from the already pasteurized milk leaving the system, and heat exchange occurs across the PHE plates in a counter current motion of the two fluids of different temperatures, right. And this, if we cannot show the video here, the regenerative heating raises the temperature of the milk to about 40° centigrade to facilitate easy standardization. Heating then continues to 60° centigrade to facilitate easy homogenization of the fat globules, because homogenization, when you will see that time, you will see that homogenization is also dependent on the temperature of homogenization, right. Homogenization efficiency increases if the temperature is high. If the temperature is low, homogenization efficiency also decreases. So, that we have to keep in mind, right. So, let me also then we come back to the next, that is after clarification, standardization. After clarification, standardization and homogenization, milk passes into the heating section where milk exchanges heat with steam across the PHE plates. The steam heats the milk to over 72° centigrade, which is the perfect high temperature short time pasteurization condition. Once the milk has attained the pasteurization temperatures, it moves into the holding tubes. The length of these tubes have been calibrated with the flow rate to ensure that milk stays at the temperature at least for 15-16 seconds. 16 seconds is for all safety, because 1 second is nothing, right. So, by the time you count, it is already second over. So, better to be over than under, because over though is not desirable, but at least will not spoil the milk in future. So, you can rely on that your target is achieved. So, that is why 1 second excess, that is why 15 second we have said, 16 second if we measure, and the length is designed such a way that it moves through 16 seconds in the holding section. So, this time is sufficient to destroy the target organisms or pathogen according to the D value which you have already seen, right. Now, if the milk fails to attain the required temperatures, the flow diversion valve diverts its flow back to the heating section to ensure that the temperatures are sufficient to kill all the target pathogens and their spores. So, this is a vital thing that might not have been by chance, the temperature could not have been attained, whereas it has passed through the exit valve. Then what to do? So, there is a flow diversion valve by which this fluid is again, this milk is again diverted to the heating section, such that all the organisms are target organisms are killed, or target organisms are killed, so that the pathogenics are also automatically killed. Once the milk is fully pasteurized, it moves back to the regenerative heating section to raise the temperature of the incoming chilled milk. In the process, the temperature of the outbound pasteurized milk drops to about 32 degrees centigrade. Such a good heat transfer, such a good heat exchange, right, that the outbound temperature is the exit of the already pasteurized after chilling, after heat exchange in regeneration section, it comes down to 32 degrees centigrade. Pasteurized milk then moves to the cooling section of the pasteurizer, where chilled water or pH coolant, that is your in this case coolant is one, which one, which is going for pasteurization. So, that is the coolant, because that is already chilled, it is started with 4 degree. So, it is getting, it is chilling the outlet of the pasteurized milk, and that is brought down to 32, and this is again going up to around 40, because you started from 72, right, further lowers its temperature to 4 degrees centigrade. Okay. Then, because ultimately this 32 degrees centigrade you have to be again brought down to 4 degree, so that be safely kept for long time. Now, advantages of regenerative heating is that there are lot many advantages, that utilization of the incoming chilled milk to cool the outgoing hot pasteurized milk increases the efficiency of the pH. A smaller amount of heat energy is required to heat the milk to pasteurization temperature, since the heating does not start from 4 degrees centigrade. Had it been you just calculate MCP delta for a given M, for a given Cp, if delta T in this case will be for 4 to 72, so 68 degrees centigrade, whereas if it is preheated, or if with the residual heat having the already pasteurized milk, so that is exchanging. So, it is brought to around 40 degree. So, your MCP dt will be from 72 40 to 72. So, around 32 degree 32 degrees centigrade. So, heat requirement will be much lower, efficiency of the pasteurizer will go up. So, this is the good system for regeneration of heat. So, reduces the amount of time required to pasteurize milk, and you must keep in mind that when starting the process of pasteurization in the PHE, milk is circulated in the heating section until it attains the required temperatures before regenerative heating begins, right. So, starting the process of pasteurization should be such that in the PHE, that milk is recirculated or circulated in the heating section until it attains the required temperature before the regenerative heating begins, right. So, okay. Now, let us go very quickly this, because our time is very small, may not be there. So, low temperature long time, similar this method is best for batch pasteurization, that we know. Let us look into batch pasteurizers for home use. Okay, then we will also review the ice cream makes cream pasteurizer that is capable for commercial use, right. And ultra high temperature pasteurizer, so where it is very high, around 135 degrees centigrade, 135 degrees centigrade, 150 degrees centigrade for 1 or 2 seconds, it is ultra high temperature, or UST milk that can be kept for 9 months without refrigeration. So, despite the risk of Maillard browning, UHT pasteurization remains the most popular preservation method for safe and stable milk, right. So, up to UHT pasteurization, let us stop today because our time is up. Thank you.